Hello. Today we're looking at two concepts, still dealing with atoms and touching on the periodic table, but we'll go more into the periodic table later. Today we're looking at atomic number. And with atomic number, uh, the atomic number is going to tell you how many protons are in a particular element. So if you look down at this picture, we have helium, and this is the abbreviation for helium, He. This would be what it would look like on the periodic table. And then there's a 2 at the top. The 2 is the atomic number. That atomic number tells you how many protons are in the atom, okay? And that's important because an atom is defined by how many protons it has. If you have 1 proton, that's hydrogen. If you have 2 protons, that's helium. 3 protons would be lithium. So it changes based on the atomic number or the number of protons. In the nucleus, as we've stated before, we have protons and neutrons. Those two combined, the protons and neutrons, will give us something called a mass number. So let's take another look, or a deeper look into that. So down here in this picture we have a description of the mass number. So we have two things that we're adding together: the number of neutrons in the nucleus added to the number of protons in the nucleus, and that will give us a mass number. When we saw helium before, helium had 2 protons in the nucleus, and it also had 2 neutrons in the nucleus. So we add the 2 neutrons to the 2 protons, and helium would have a mass number of 4. Okay? So pretty straightforward. Okay, so the next step is to do a few practice problems with what we know. And we're going to see a notation like this right here, where it says Na, which is the symbol. This is sodium. Na is sodium. It may or may not have a charge up here. In this case, sodium does have a charge, and it's a positive charge. It has a 1 positive charge. We'll deal with charges some more later. But the important numbers are going to be these ones off to the left. So we've got 23 and 11. At the bottom, 11, that's the atomic number. Remember, that's the number of protons. And at the top, we have the mass number. And that is going to be protons plus neutrons. So based on these two numbers, I know the number of protons, and I can figure out the number of neutrons if I just take this top number, 23, and subtract the bottom number, in this case 11. So we're going to do a couple practice problems. All right, so we're going to take a look at a couple practice problems. You'll see that I'm on page 112 in our textbook. And we're just going to be down here figuring out some basic compositions of these atoms. So we're going to start right with 17. How many neutrons are in each atom? So let's write this out. A is 16 over 8, and then O. So I know this is oxygen for 2 reasons, based on the symbol, but also based on the number of protons. I know that protons plus neutrons is equal to 16. So the question is, how many neutrons? And I would just take the 16 minus the 8, and that will give me the number of neutrons. So in this case, 16 minus 8 is 8. Okay? You can do that with the other ones as well. Follow the same pattern for each of these. It's done in the exact same way. Now on 18, it says use table 4.2 to express the composition of each atom in shorthand form. So A, what they're asking for is carbon 12. If I turn back to this page, to the table they were talking about, this is table 4.2. They want me to write carbon 12 in this notation here, okay? So I know what the symbol is for carbon. That is C, okay? So carbon C. Now carbon 12. So the question is, what does the 12 mean? And 12 is actually the mass number up here. But what about the bottom number? How do I know what the bottom number is? By definition, carbon will always have the same number of protons, and that bottom number, remember, is protons. So this is always going to be the same. For carbon, if we look here, carbon has 6 protons. So I know what the total mass is, I know what the number of protons are, I know the symbol, and that's the shorthand version for writing carbon 12. I could also have other things, like I could have carbon 14, okay? In that case, I still have 6 protons no matter what, but my mass is now 14. That means I've added 2 extra neutrons. That's how I went from having a mass of 12 to a mass of 14. 2 extra neutrons. That's what carbon 14 would be. All right, thank you very much.